simple trig graphs. First one we're going to do is sine theta and figure out what the sine theta look like on a graph. As you have remember that we've done other functions like y equals mx plus b. What does a something like y equals mx plus b look like on a graph? Anybody? Line, thank you. One person said line. So then I say, what does a quadratic look like on a graph? Anybody? What's a quadratic look like on a graph? Quadratic. A parabola? A U? Yes? Okay, so what does an exponential look like on a graph? What does an exponential function look like on a graph? Somebody say a ramp. I think I'm deaf, and I think I heard somebody say it looks like a ramp, something like that. In any case, after we're done with this, this plotting the points, we're gonna give it a name to what sine theta looks like. All right, but before that, let's get the points. Something's flashing again. Shh, don't say anything. Something's flashing again. Let's go with Brandon. Brandon, you see that flashing right there, Brandon? What are the coordinates of that point right there? What are the coordinates of this point right here? What are the coordinates of that point? 1, 0 is correct. Yes, 1, 0 is correct. So Brandon said it was 1, 0, which is absolutely correct. Everybody, look up here. What did we say the x coordinate? That's cosine theta. We're not graphing cosine. We're graphing sine. So I don't care about this for what we're doing here. I care about the y value because sine of 0 is going to be 0. And I just want to get the y coordinates. Understood? Yes. Okay. Now, let's go. Annalise, what are the coordinates of that thing that's flashing up there? 0, 1 is correct. 0, 1 is correct. You could go ahead and put that number, but we're not concerned about the x. We're concerned about the y. So I'm going to getting you going with this. And we're reviewing this stuff. What are the coordinates of that one right there, Xavier? What are the coordinates of that thing that is flashing? You said negative 1, 0? And we're only concerned about the y for right now. Good. William, what are the coordinates of that thing that's flashing?
0.
Both coordinates. Huh?
1, 0.
What?
0, -1.
0, -1. 0, -1, everybody? Yes? 0, -1. Yes. Okay, now, let's get the coordinates of those. Remember we did a quiz last week about that? Remember that I told you that watch YouTube videos and they go their little things about how to remember these things. Square root of 1 on top, and then we got the square root of 2, which I don't have, and then square root of 3. And then we start over from down here. We're going to go what? Square root of 1 is 1, square root of 2, square root of 3 up there. Okay, let's go. And I'm only putting the y value because we're trying to graph the sine. Okay, so we got that. And I'm telling you, don't get confused on what happened to the middle, or I just decided not to include that because it just doesn't even fit. Okay. Now, I'm not asking about the x here. I'm asking about the y. What is the number that goes here for the y on that one, Aaliyah? What's the y value of this one? What's the y value of this one? Huh? 2? How the heck is it going to be 2? Come on. No. What's the y value? Frankie, what's the y value of this? Oh man, you're looking at your notes. You're going to go look at your notes. People, look up here. People, it's half the class. I asked, what's the y value of this? Look up here. it is reflected about this is going to go here. The x is going to be negative, which I don't care. I'm asking about the y. The y is going to be on top. Is y? The answer is square root of 3 over 2. And it's positive because on top, yes? Okay. Xavier, what's the answer? Well, what should be the number here? It's telling you it's positive. It's giving. Did you say 6? What the heck did you say? Bless you. What is the number that goes in here? Xavier, you haven't been here. Oh, you haven't been here because you're going to. It's this number. It's reflected over here. It's gonna be 1/2. Yes, people. We did this so much the other day. It's just that one. So this one's gonna be 1/2. Okay. And now my next question is over down here. Alexis, what's the number that goes in here?
2 square root 2.
Loud.
Square root 2 and 2.
No, don't. Why are you doing square root of 2 over 2? No. We don't even have square root of 2s in here. No, we don't have pi by 4s. It's gonna be which one? Come on. This one is gonna go with, and we're looking at it's gonna be what? It's gonna be what? But it's going to be what? Negative because it's under. Negative 1/2. Richard, what should go here? Loud.
Negative square root of 2.
Do you not know what you're trying to say correctly? It's gonna be what? Do you know how to say this? You don't know how to say this? That's the problem. What?
Square root 3
Over
2.
But it's negative. Yes or no, people? Yes. Negative square root of 3 over 2. Yes, because the y. And let's go over here. What would be this one? What would be this one? What would be this? Juliana, what's this one? Let's shoot. Negative? Because it's under. Negative root 3 over square root of 3 over 2. Yes? And then finish it off with this one. It's going to be what? Anybody? Let's go. Negative 1/2. Get it? Hey, it's all reflection. It's all a mirror. This is a mirror and then a mirrors or whatever. So they go like this, they go like this, and they go like that. All right? Okay. Let's fill them out. So now, here we go. I thought I said I was going to stop. Lucky. What's sign of 0?
1. Oh, 0, 0.
Is it 1 or 0?
0.
It is 0. Why is it 0?
Because it's the sign like theta is the y-axis.
Yes, it's 0. Yes, sine 0, 0. Everybody, let's fill it out. Sine pi by 6. Sine of pi by 6. Sine pi by 6. Be quiet. Jacob, sine pi by 6. 1/2. 1.5. It'll be 1.5. No, 1/2. Let's get this going a little quicker. Let's sine pi by 3. Sine pi by 3. Jorge. Sine pi by 3. Huh? Sine of pi by 3. It's like why are you not looking at me? It's going like this to you. The pi could, no, it is the root. The root 3 over 2. Trinity, sine pi by 2. One. Lainey, sine 2 pi by 3. Sine of 2 pi by 3. Huh? 2 pi by 3? Yes. Square root of 3 over 2. Yes. Yes. Sine 5 pi by 6. Sine 5 pi by 6. Francisco. Easy. 1/2. Sine of pi. Sine of pi. Luis. Sine pi. 0. Sine 7 pi by 6. Sine 7 pi by 6. Aliyah. Sine 7 pi by 6. Yes. Yes. Denise, sine 4 pi by 3. Huh? Negative. Sine 3 pi by 2. William, sine 3 pi by 2. Huh? Sine 3 pi by 2. Xavier, sine 5 pi by 3. Negative root 3 over 2. Negative root 3 over 2. And everybody, sine 11 pi by 6. Anybody? Let's go. Negative 1/2 and whatever. Okay, good. Let's plot the points. Let's go ahead and plot the points. So this is going to go -1 to +1. Okay, so it's going to go input is 0, output is 0. So it's going to be 0, 0. So this is going to be at 0, 0. Okay, now I got to cut it up into 3 pieces from 0 to pi by 2. Because that's 0, 30, 60, 90. So let's cut it up. Let's go right here. Cut as best you can cut it into 3 pieces. The whole from 0 to pi by 2. And put pi by 6 here. Pi by 3. Let's go. Pi by 3. Pi by 2. Then we got 2 pi by 3. Cut it into 3 pieces in here again. That's going to be 2 pi by 3. And then you got 5 pi by 6. Pi. 7 pi by 6. Cut it into pieces, 3 pieces. 7 pi by 6. 7 pi by 6. 4 pi by 3. 3 pi by 2 is going to be there. And then 5 pi by 3. 3 pieces. 5 pi by 3. And 11 pi by 6. All right. So now we got them just to know where they go on the x-axis. And pi by 6, what's the output of pi by 6? Everybody, the output is what? 1/2? So if this is $1, half a dollar is going to be, pi by 6 is going to go to 1/2 right there. That's 1/2. Pi by 3, okay. I remember I told you that root 3 over 2, if you put in a calculator, what's root 3 over 2? Who remembers? It's 0.866, it's 0.87. 87 cents. 87 cents. Pi by 3 is going to go to 87 cents. Dollar, like right here. It's an approximation. It's an approximation. Pi by 2 goes where? Come on, let's speed it up. 1, everybody guess? Look it up there. Pi by 2 goes to 1. 2 pi by 3, what's the output of 2 pi by 3? Give it an approximation. 0.87, 0.87, about 0.87. 2 pi by 3, 0.87, so it's going to be on the other side over here. 5 pi by 6 goes to what? 5 pi by 6 goes to what? 1/2? 5 pi by 6 goes to a half. What's the output of pi? Output of pi? What's the output of pi? 0. What's the output of 7 pi by 6? What's the output of 7 pi by 6? Negative 1/2. 7 pi by 6 is negative 1/2. Somewhere there. 4 pi by 3. Output of 4 pi by 3. Approximation. It's negative 0.87. 0.87. 4 pi by 3, negative 0.87, somewhere over here. The negative 1, and you could see it's all reflected about the same. And I connect these dots. I connect these dots. And now I know what a sine function looks like. I've been saying it for a long time, more than a decade. I say a quadratic looks like a parabola, looks like a U. A quadratic function looks like a U. What does a sine function look like? Let me ask you. What does that thing that I just drew, what does this look like? You tell me. It looks like a what? It's a wave. Actually, well, it is a wave. But what else? What else? Can we stay? Somebody go ahead. Yes, it looks like that. But what else? Like I said, a parabola, exponential function looks like a ramp. I call it like a ramp because, somebody's on a ramp and does their little. So what does this look like? I'm just saying so we can remember. What does it look like to you? What does it look like to you? I call it a sideways S. People, look. Some people might not agree. Do you know like an S? Yes or no? This is an S? Yes or no? Yes? And then they kind of like turn it. And so it kind of looks like a sideways. I'm just calling it, I'm not changing. It's a sideways S, okay? So whenever I say, hey, what does the sine function look like? And you say, it looks like a sideways S. There, look. Now we know what the parent function is. There it is. There it is. Yes or no? Lucky, yes or no?
Yeah.
Yep. All right. Let's go. Now we're going to do transformation to that parent function. Make another graph quickly. What? All right, let's go. Copy it down, everybody. Is it 24? 2024? Yeah. Oh, we got 5. We got a little bit of time. Let's go. We got time. 58 and 16. Okay. Here we go, everybody. Let's go. You don't need to copy this down right here, this circle. You don't have to. Just it's going to be there for your visual so you'll know what I'm talking about, where the answers are at. Go ahead and write down the T-chart. And let's have these inputs. 0, pi by 2, pi, 3 pi by 2, 2 pi. You don't have to copy this circle down. It's just giving you the answers. The answers are there. For theta, we're going to plug in 0. So basically, I'll do it for 1. Sine of 0, and then we're going to times it by 3. To get the output. What's, let's see. No, let me go. Lady, sine of 0. What's sine of 0? What is sine of 0? 0 is correct. Sine of 0 is 0. Yes, you're looking at that 0. So what 0 times 3 is? 0. Yes. Sine of, don't say anything. Brandon, what's sine of pi by 2? 1. Sine of pi by 2 is up here, and it's 1. And what's 1? That's what the answer is for pi by 2. Sine of pi by 2, what's 1 times 3 is? Yes or no? I'm doing this quickly. Get going because we don't have that much time. You know we're plugging in pi in for theta. Sine pi, Marco, sine of pi? 0. And now we got 0 times 3 is 0. Yes? Annalise over there. Annalise, what's sine of 3 pi by 2? Negative 1. Yes, easy. Sine of, that's going to be down here. Negative 1. Negative 1 times 3 is what? Negative 1 times 3 is negative 3. And sine of 2 pi, everybody, sine of 2 pi is? 0 times anything is? Let's plot these points. So we got what? So let's go ahead and plot the points. Let's have pi by 2, pi, 3 pi by 2, 2 pi. Okay, I decided, we already know what a sine function looks like. A sine looks like a sideways S. That's what it looks like. We're not going to do so many points. We already kind of know what we're looking for. We're looking for some sideways S. Okay, so 0 goes to 0. Pi by 2 goes to what? Pi by 2 went to what? 3? Pi goes to what? Pi goes to what? You have it. You wrote it down. 3 pi by 2 goes to what? Negative 3? 2 pi goes to what? And we connect those dots in a wave, in a sideways S. Now, without doing all this work that we just did, what happens when we put a 3 in front of it? What has happened to the original function? Let me draw you the original function. The original one we just drew was this one. What happened to this blue original sideways S? What happened to it? It got what stretched? Vertical stretch. It got stretched vertically. So it's a vertical stretch by a factor of 3. So what happens here is that if this 3 changes to a what? Like a 5, what's going to happen? If I change this to a 5? It's going to go all the way to what? To 5. Yes or no? Yes. You get the idea now then? All right. So that's what happens when you put a number in front of it. All right. I think we're going to finish off with number 2. Here's number 2. What happens when we put a number in the inside next to theta? We make a table again. So let's do the I'm gonna do it here. Sine 2 times 0. Plug it in 0 for theta. Two times 0. 0. And so what is sine of 0? 0. Yes or no? Do I need to explain this whole thing? 0 times 2 is 0. Sine of 0 is the unit circle. Sine of 0 is 0. 0. So sine of 0, sine of, when you plug it into this particular function, 0. I still have it, I put it there. Okay, if you plug in pi by 2 for theta into sine 2 theta, let's go ahead and do it. I'll do the work here. Sine, you got the 2 is there, and then pi by 2. Pi by 2 is here. What's going to happen with the 2? Cancel out. So we're going to have sine pi, no? What's sine of pi? Sine of pi? 0. Pi is over here. Yeah. 0. Yes, 0. Let's continue on here. Sine of, we're going to plug in pi, so it'll be sine of 2 pi. What's sine of 2 pi? Isn't 2 pi over here? 0. 2 times. We're going to plug in 3 pi over 2. What's going to happen with 2? Cancel out again. So I'm going to have sine of 3 pi. Look. Let me show you guys. Now you're all confused. What is 3 pi? Look up here. Pi, 2 pi, 3 pi, 4 pi, 5, 6, 7, 8, 9, 10. Huh? You get it? You're like, no, I don't get it. It's odd number. It still be 0. It doesn't matter. You still can't be wrong. It's still 0. So it's all zeros. Either left or right, they're both zeros. All right, let's plot. So it's going to be what? 0 go to 0. 0 go to 0. Pi by 2 go to 0. Pi go to 0. 3 pi by 2 go to 0. 2 pi go to 0. Uh-oh. Is this a straight line? Is this a straight line? No. We don't know what's happening in the middle. And what did we say sine looks like? It has to be something like this. So, let me show you what's going to happen. Look. So we only got like 5 minutes. Look. Watch. How many sideways S's are there here? How many sideways S? Okay, let me change the color so you see one. This is 1. That's 2. What happens if it was 3 theta? 1, 2, 3. What if it's 4? 4. If it's 1,000. 1,000 in there. Yeah. Hey, look, cosine theta, we're running out of time. Cosine theta, you do all the work. We're going to do it now this time, everybody, because we're running out of time. We're going to do cosine theta. We're looking at here. Instead of looking at the y, for cosine, we look at the what? X. So cosine of 0 is 1. 0 for the next 0. And then you plot the points. It's going to be... I call it what? I call it Hollister bird. You know what I'm talking about, Hollister bird? Yes or no? Yes. Hey, when you do the homework, go ahead and use decimals. Put it in decimals, change the x. I'll tell you already, change the x to pi, to radians. So then you can just copy the graph. We good? We good? We're done.